Hi everyone, welcome to my channel and I am Subhash Chandra. If you are my follower and have subscribed to my channel, you must have seen me posting videos for piping design subjects. That's because my primary goal is to help those who are interested in piping design engineering to understand the industrial requirements and the experience that is required for a real-time job, and to also understand the skills that are required to become a perfect piping design engineer. So the primary intention of any piping design engineer is to develop a good piping system that can withstand all the failures which are generally happening in the piping design industries, piping industries, so that you can design the system to mitigate those failures. So isn't it important for a piping design engineers to understand what are the common failures which are generally and predominantly happens in piping industries, so that you can consider those causes and design the system accordingly, so that you can develop a system that can withstand these failures. Because if you don't consider these scenarios and the requirements, then your piping systems are prone to failure if it has to face such a scenario. So in this video, we are going to discuss about 10 different failures, the reasons for the failures of a piping system, to understand, so that you can better design the system and take necessary action while you are preparing your piping design deliverables actually. So that once you bring all these details in your drawing, it will go to construction, and if the constructions are done based on your drawing, you can ensure that your system is safer. So without wasting your time, let's start from the first failure actually. Corrosion. Corrosion is the predominant failures in piping. What are the types of corrosions? I'm not going into different the modes of corrosion. I'm just giving you an idea about the major failures in piping. So if you take corrosion, you have two different types of corrosion: internal corrosion and external corrosion. Internal corrosions are basically due to the change of properties of the fluid, or the properties which is not compatible for the material chosen. So basically for the internal failures actually, you have to ensure that the material chosen for your piping system for a particular service is recommended by the material and corrosion engineer. And if you have any concerns, if you have any prior experience that you have made this piping but still corroded, then you can go and speak to your material engineer to reconsider the material evaluation. This is for internal corrosion. And for external corrosion happens due to various changes in the atmosphere, especially if you are near to the sea, or if you are near to the environment where the chloride contents are more actually. Slowly over a period of time, it may not happen within a week or month, it may happen over 10 years down the line, that your external surface of your piping will be corroded actually. So basically, to avoid external corrosion, you have to choose a painting system which will be applied over the pipe and over the fittings, entirely over the piping network, so that it can withstand the external corrosion. This is one factor actually. Now let's see the second failure. The second failure is, this is also one of the most commonly happening issues in the piping system. Whatever topics that we are going to discuss in this particular video are a general failures which the piping design engineers has to consider during their development of design. So the second problem that I would like to highlight is that flow induced vibration. Make it very clearly, flow induced vibration. So this happens in all the services. It happens not only in the critical services like steam and hydrocarbon and toxic. It generally happens in most of the services. So you have to ensure that your piping system can withstand the flow induced vibration. So basically how this is done, so I'm not going to what are the mitigations that you have to take, because each and every company has their own standard. So if you have some documents which is from the client, that is could be the specifications of your company, or could be the client recommendation, please go and ensure the mitigations that you have to take for flow induced vibration. Just giving you a hint actually, Generally, flow-induced vibrations happens when the velocity of the flow is more, and these parameters are being addressed by the process engineers in the line list, or they will send you a separate list where the flow-induced parameters are highlighted. So for those lines, what you have to do, you have to ensure that the vibrations are less by making this stress analysis in softwares, and to ensure that your vibrations are really low. So this is one of the common failures in piping system. So ensure that these lines are analyzed and your vibrations are reduced as per the client expectation or the specification which you already have actually. So this is about the second. Now let's go to the third failure. The third failure is support slip. Have you ever heard about support slip? Let me explain the scenario of it. Support slip means your support which is supposed to be placed either over the concrete or a structure got slipped. This slip because of various reasons. One of the primary reason is that thermal expansion. So the thermal expansion which is supposed to be considered during the stress analysis were not considered. That's because the temperature which is influencing the thermal expansion were not considered properly. So as a piping design engineer, you have to ensure that the maximum temperature of the line being considered or not. So you have to verify this parameter with the process engineer and ensure that this parameters is gone to piping stress analysis and they have analyzed the system for this temperature, so that you can ensure that your analysis are done for this temperature, and also you can prevent the support slip scenario. Now let's go to the fourth failure. The fourth failure is support damage. Support damage is again the kind of failure which is because of the results of not considering the right parameters in the stress analysis. Say for an example, if you have designed an anchor is something which is completely locked in one particular location. So how it actually functions, you must have a shoe supports or whatever be it at the bottom of the pipe that must have been welded to any structural support or any concrete support. So if the load of the anchor is not properly considered, so what happens is that this anchor will failure. If in case the anchor is too strong, it will completely demolish the structure and it will pull off the foundation if it is placed over the foundation. So support damage is crucial because your parameters which supposed to be considered in the analysis were not right actually. So being a design engineer, what you can ensure is that you can discuss with the piping stress engineer and to ensure that all supports are designed for the maximum load. You can either consider 25%, 30% more load because to prevent such scenarios. So let's say that you have your design value is somewhere around 200 kg. You can consider the support design for 300 kg. So likewise, you can ensure the supports will not be damaged during the actual operating condition, because support damage is basically the result of not considering the right parameter in the stress analysis. So these things you have to keep in mind, because it's a role of piping design engineer to ensure that the system is properly designed or not. Though multiple teams are involved like stress and material, that's where the role of the piping design engineer is very important in any particular company. Now let's go to the fifth failure. Welding joint failure. Welding joint failure. See, welding joints are known to be the strongest joints. There are multiple reasons for welding joint failure, but here I wanted to address the only piping design areas actually. Say for an example, you have one welding joint and immediately near to the welding joint you have a flange connection. And near to the over the flange, imagine that you are going to install the valve actually. So the valve weight you have considered as 100 kg, but the actual valve weight could be 500 kg. What does it mean? So these 400 kg which is not considered in your system will directly impact your welding joint. This welding joint will not fail over a week or month because it's one of the strongest joint. It will happen over the years, after 5 years or 10 years, but you may not know when it will happen. That's because since I said welding joint is a strongest joint actually, it will go through the tremendous stress because of your additional load. And this stress will create a fatigue kind of failures in the welding joint. So over a period of time, the welding joint will lose its mechanical and material integrity. So that's where your welding joint actually fails. This is one reason, and the another reason is that I could, as I said, the flow induced vibration. If there are continuous vibrations and which is not addressed in your piping system, these vibrations are really going to damage most of the welding joints, which is near to the vibration source actually. So you have to consider that your welding joints are more critical. So ensure that whether your valves are properly supported, weight of the valves are properly considered, induced vibrations are properly considered or not. So now let's go to the sixth failure, gasket leaks actually. How come gasket can leak? Because the gaskets are within the two flanges, and how come it can leak actually? I'll tell you one of the reasons. See, piping system is a dynamic system. It is not a static system. Though it appears to be static, it is dynamic because you have the live service which is going. This live service that flows within the piping will have some movements. And all these movements will not impact the body of the piping because body of the piping is too solid. Where it will impact? It will only impact the flange joints. That's why most of the flange joints are stronger compared to your body of the piping. But there are cases that if the movement of the piping is too high, it will slowly damage the gasket because there will be a cushion in the gasket. So this will impact the gasket performance actually. So, and moreover, if the service is high pressure service, the high pressure will flow out of this small gaps. So basically how to avoid is that you have to ensure if the line is highly rated and high pressure service, and please conduct a flange leakage testing from the stress analysis to ensure that the moments and the deflections are less. Basically, it happens because of more deflections and moments systems in the piping. So you have to ensure that the critical flanges are static and has less moment and less deflection. If required, you can provide some multiple strong supportive supports like guides and anchors if required. Anchors are not recommended everywhere. Anchors are recommended only as per the stress analysis. I'm just giving you an idea. You can provide a guides to ensure. You can provide limit stop. You can provide hold down. So there are different types of support that you can ensure these moments can be less actually. Now let's go to the seventh failure. Seventh failure is a nozzle failure. How come nozzles in piping gets failure? See, the nozzle that I'm trying to address over here is that the piping systems are connected with equipments. So equipment has got nozzle. If your piping loads are not properly considered, and say for an example, it is considered in the stress analysis, but in the piping design, you have not provided support with respect to what the result you have received from the pipe stress analysis. So there will be a lack of communications or a miss from your side. So what happens, the supports that has to be placed near to any equipment nozzle, if you have forgotten actually, the loads will be transferred to the equipment nozzle, that will failure. Remember, equipment replacement is too costly in process plant compared to piping changes. That's where we always have to ensure that the equipment is safer. So you have to ensure that no additional load goes to nozzles, and you have to ensure the supports are properly placed. Those supports are critical supports. So all critical supports are properly placed or not. You have to ensure that the equipment is perfectly safer. Otherwise, it is going to cost more. This is one nozzle I can say. What about branches? See, piping system has branches which is connected to another piping also. There is a continuation of the piping. If you are not going to understand the relation between the dynamics of the piping, thermal expansions and the load that are being distributed from the other line to the branch nozzle, then it will damage the branch nozzle also. It will damage the entire header T-junction, and it will damage the flange connection also. So in order to avoid all these things, you have to ensure that you have provided supports in line with the stress analysis report. Double check the support location, because if there is a miss from your side, it will be a catastrophic damage in your piping system. Now let's go to the eighth failure. Eighth failure is elbow crack, elbow body crack we can say actually. Let's say your piping system has multiple elbows and one of the elbow got cracked. As I said, these cracks will not be immediately. It will be after 7 years, 8 years actually. But during the crack, if the service is hydrocarbon, we may not know the situation during that point of time at site actually. If anybody near to the crack got exposed, and it can take their life. So it's very important to understand all these failures actually. So how the elbow crack may happen? I'll tell you a scenario. Let's say you have an elbow and you have a trunnion support below the elbow, and your trunnion support is anchored from all directions. Let's consider this scenario. And your service which goes into the piping has a slug flow. Slug will cause an enormous amount of force in the elbows because slug will always impact the piping system which has a change of direction. So what is a change of direction? Change of direction happens only in elbow. In T it will not happen. That's because the force can directly travel to the other side. But only in elbow you have to divert the forces actually. So there is no way to bypass this force. This force has to hit at one corner, then only it will go up. So the continuous hitting for a prolonged time will cause the force to get transferred in the support. Since the support is anchored, this force will directly impact the elbow. Over a period of time, the welding joint from the support and the elbow will get cracked and it will damage the body of the elbow. So to replace it, you have to shut down the line, you have to modify these things, whether you will not know whether shutdown will be available or not. In that case, you have to stop the production. All of this will be the after result of this failure. So these things you have to understand. So accordingly, you can consider the slack force in the piping system. So piping design engineer has to ensure that these inputs are received from the process engineers or not. So you may ask me that most of your failures are related with piping stress analysis. No, it's not like that. Piping stress analysis is the mechanism to do the analysis, but the parameters are very important. These parameters has to be received from process engineer. Process engineer has to give it to the piping design engineer, and piping design engineer has to transfer this information to stress analysis engineer. So piping design team does the major coordination between these two disciplines. So remember, these are critical parameters that has to be gone to piping stress analysis. Now let's go to the ninth failure, material peel off at the bottom of the piping. What is material peel off at the bottom of piping? See, imagine your pipe is not rested on the shoe support, it is directly rested on the structural support, and your piping has some certain temperature so that it can expand during thermal condition, I mean high temperatures. So during thermal expansion, this line will expand. When the temperature goes down, it will come back to the same, it will contract and come back to the same original position actually. So this back and forth movement happens continuously and for 24/7 throughout the year and throughout the decade actually. So this will cause an erosion at the bottom of the piping which is touching either the concrete or a structure. So slowly it will peel off the material from the bottom of the pipe. You may not know, from outside your piping may look fantastic actually, but over a period of time your thickness of the piping at the bottom may get loosened actually, so that if your service is a high pressure service, it will cause a pinhole damage directly, and it will cause a potential hazard to the people who are working around this particular area actually. So how to avoid it? So you have to ensure that if the line has a temperature, you have to ensure that this line has supported properly, not directly placed on the structure. If it has to be placed on the structure, you have to ensure the wear pad is provided. You can call it as a reinforcement pad, or you have to just place a shoe support so that you can avoid the erosion at the bottom of the pipe actually. So this is one failure. Now let's go to the 10th failure. The 10th failure is one of the predominant cause of failure in piping system, which is because of the vibration. So it's important for piping design engineer to understand all source of vibration. Let me just tell you a couple of source of vibration. One is, if the line is connected to any rotary equipment, definitely you will have a vibration scenario. So you have to ensure that the vibration is controlled by putting the appropriate supports in the piping system as per stress analysis. Analyze the line for the vibration and provide the supports according to the analysis demand basically. And second reason is that, let's say that you have a non-critical line and you have not envisaged any vibration in the system, but over a period of time you have rested the supports, you have rested the pipes over a support. See, over a period of time, if a couple of supports gone down, there will be a gap. So gap between the bottom of the pipe and the top of your structure. So what happens when the service passes actually? This will cause a a momentum. It will cause a slow sagging up and down. This sagging up and down over a period of time will cause vibration. If it becomes continuous, it will become a continuous vibration with sound and hammering, because the line is going to touch the structure. It is going to be continuous hitting over the structure. This is another way. And another way is that, as I said actually, if you have not provided support with respect to the stress analysis, then also you can experience the vibration, because your line has got vibration and it was analyzed, but during implementation it was not properly provided. Either it's a miss from the piping design engineers or a draftsman, or it's a miss from the construction, both scenarios. But piping design engineer has to ensure that whether these systems are followed, whether it is analyzed, whether properly implemented, whether scenarios and parameters are considered or not actually. This is another scenario. And next scenario is control valves. See, control valves are prone to initiate this vibration problem, because the control valve, at the control valve, there will be a phase change of the fluid. The phase change of the fluid creates some sort of a heavy vibration. This will cause a surge. This will cause a shake in the piping. So you have to ensure that properly these systems are supported or not. So these are the 10 different failures that as a piping design engineer you have to keep in mind, so that you can ensure your design is perfectly made to withstand these failures. So I will meet you in another fantastic video. Until then, bye from Subhash Chandra.